In this short video, we are going to use integration by part to solve an integration problem. The problem is evaluate the integral tangent inverse of x dx. Here's a formula for integration by parts. Okay, so we know the integral is tangent inverse x dx. This means that tangent inverse x is this u of x times v prime of x. So now you see that the integrand in this case is only one factor. So you need to decide what is what in this case. So we see that if we set v prime to be tangent inverse, to get v will be very difficult because we don't know the integral of tangent inverse. If we did, we won't even be solving by integration by parts. Therefore, we are going to set u of x to be tangent inverse of x, which means arc tangent of x. That means what? U prime is 1 over 1 plus x squared. Now, because u is equal to tangent inverse, it means that v prime of x is 1. Because if you can only multiply tangent inverse x by 1 to obtain tangent inverse x. And that means the integral of v prime, which of v in this case is x. So the given integral tangent inverse x dx is therefore u of x v of x. U of x is 1 over, u of x is tangent inverse x, and v of x is x, then minus the integral of v of x times u prime of x, 1 over 1 plus x squared dx. So rewriting this, we get x tangent inverse x minus integral of x over 1 plus x squared dx. Now, the basic rule of integration, if we look carefully at the integral to the right, we see that if you take the derivative of 1 plus x squared, that should give you 2x, meaning that the numerator is a constant multiple of the derivative of the denominator. So if we say here in this problem, do change of variable here, saying that let's say t is equal to t is equal to 1 plus x squared. That means dt is going to be 2x dx. And if you want to solve for dx, so dx is going to be dt over 2x. In doing this, our integral becomes integral of tangent inverse x dx becomes x tangent inverse x minus integral of x over t times dt divided by 2x if you want. So, and now we can cancel out x and x cancel out, and we obtain x tangent inverse of x minus 1/2, bring the 1 that is underneath dt to the front, 1 over t dt. So, and in this case, it gives you, if you integrate 1 over t dt, it is ln of absolute value of t. So x tangent inverse of x minus tangent inverse of x minus 1/2 ln of absolute value of t plus constant. But we don't want t in our final result, so x tangent inverse of x minus 1/2 ln of 1 plus x squared plus constant. See that I dropped the absolute value because 1 of plus x squared is always non-negative, or always positive actually, so which is good for ln.